Good morning, my dear students of class 10th. I am your physics teacher, Miss Rajwantkaur. As we was doing the chapter number 10, Electromagnetism, today we will do the exercise B of this chapter. So come to page number 241. So here you can see that the exercise B is force on a current carrying conductor in a magnetic field and its application in DC motor. Now, it is said by the Lorentz that when some charge is moving into the magnetic field, then there a force is experienced by that charge whose direction is other than the direction of magnetic field. That force is Lorentz force. What he said? He said that any of the conductor which is carrying a current into it, when it is placed into the magnetic field, it start experiences a force due to which there can be production of motion in the conductor. So by the experiment he shows it like this. He take a wire AC and kept it into the horseshoe magnet, and he completed the circuit by applying the battery key rheostat for the passage of current through the wire, and he tied the wire with the thread and with the support of a stand. So what he did, when he closed the key, the current started flowing through the wire AC, and what he observed that the current was into the direction from A to C, and there was a magnetic field. Here you can see that magnetic field is acting. So he found out that there was some force experienced by the wire due to which it starts giving the motion. So first what he did, when there is a no flow of current, when key is open, the wire does not move. But when the current I start flowing from A to C, there was a force F to act on the perpendicular to both the direction of magnetic field and current, which act along the positive Z direction. If the direction of current is reversed, then the force will act into the minus Z direction. So in this way you can find the direction. If the current and the magnetic fields are perpendicular to each other, then there a force act perpendicular to both the axes. So now the force will act into the minus Z direction. And if the magnetic field is reversed, like north pole is changed with the south one, so in this way, if it is done, then also the force will act into the minus Z direction on the wire. Now how you can find the magnitude of force? The force is directly proportional to the current flowing through the conductor, means it depends upon the current, it depends upon the magnetic field, and it depends upon the length of the wire. So when all of these get combined, you get F is directly proportional to IBL, and on removing the sign of proportionality you will get K. When K is 1, you are going to get F is equal to IBL, which is the value of force. Now how you can find the unit of magnetic field? For magnetic field, you will kept B at one side, and on another side there will be F by I into L. So force is having a unit Newton, and the current is having a unit ampere, and length is measured into meter. So it will be Newton per ampere per meter. Now how you can find the direction of the force which act on this wire, which is carrying a current and placed in some magnetic field with the help of Fleming left hand rule. You will make your left hand like this, and you will find the direction of the current, and you will point your central finger in that direction where the current is acting, and your forefinger will act towards the magnetic field, and when both are mutually perpendicular at that time, your thumbs points in the direction where the force is acting on the wire which is kept in the magnetic field. Next is simple DC motor. What is DC motor? It converts the electrical energy into the mechanical energy. So it also works on the principle of Fleming left hand rule. With the Fleming left hand rule, you can find the direction of force acting on the armature coil, due to which it moves and mechanical energy gets converted into the electrical energy gets converted into the mechanical energy. Now, what is the construction and its main part? There is armature coil ABCD, which is made with a soft iron core and a copper wire is wound around it. So this is the armature coil. At one end of it the axle is attached, and the other two ends of the wires are attached further with two split rings, and these split rings are fixed with the ends of the armature coil, that is A or D, and further these split rings are in contact with brushes B1 and B2, and further these brushes are applied with the current with the help of battery key and rheostat. Now what will happen when the current will start flowing through it? After closing the key, the armature coil will start giving the rotation, and like this, with the Fleming left hand rule, you can find that on the AB the force is acting into the inward side, and on the CD it is acting on the upward side, due to which it gives the anti-clockwise rotation. You can see it will give the anti-clockwise rotation, and when it gets rotated, at that time the S2 and S1 loses its contact with the brushes, but still this armature coil will move. Why? Because due to the energy of rotation, any of the things gives the same motion till we do not apply some external force over it to stop it. So it will give the same rotation whether it loses its contact with the current. It is going to rotate, and when it reach the position after 180 degree rotation like this, then CD arm is in the downward direction, AB moves in the upward, and it gives the anti-clockwise motion, due to which the split ring S2 comes in contact with brush B1 and S1 comes in contact with brush B2. So in this way current will flow from CD towards the AB. So here also the current will flow, but in the opposite direction. Now its direction will get reversed. When it reaches to 270 degree rotation, after rotation, then it also loses its contact again with brush B1 and B2. The split ring will lose their contact, but still they give the anti-clockwise motion because due to the energy of rotational motion. So this is how the DC motor works. Now how you can increase the speed of rotation of the coil? By increasing the strength of magnetic field, or even you can increase the number of turn, or even you can increase the area of the coil, and by increasing the strength of current magnetic field. So these are the ways by which you can increase the speed of rotation. Now what is the function of split ring, which is also known as commutator? It reverses the direction of current, but still the coil moves into the same direction. So it is just achieved due to the S1 and S2. So in this way these two split rings reverses the direction of current. So these are known as split ring commutator. Now what type of energy transformation takes in DC motor? As we applied the electrical energy by the battery to the armature coil, and it transferred the electrical energy into the mechanical energy.